yourself, Nagesh, and yeah, the remaining candidates. Can you please introduce about yourself and let me know why you want to learn Docker and Kubernetes? And yeah, what are your expectations towards this session? I just want to know about that.
I am Elvis Kasse. I am
Yeah.
a
Hi,
Java.
Elvis.
Yeah, hi. Sorry.
Mhm.
Hi
Go
to
on.
everybody. I am Elvis Kasse. I'm a Java developer. I
Very
have
good.
three years experience,
Mhm.
and I want to know about Docker and Kubernetes. My first approach, and
Yeah.
maybe and not maybe. I want to attend the CKAD
Mhm.
certification. So
Right.
this is my expectation.
Done. So yeah, we will discuss about that, what you are going to do. And we will see how we are going to start. Okay. So don't worry. Yeah. Another person who is attending to the session, newly to the session.
Yeah, hi, myself Nagesh. I'm a Java
Mhm.
developer. I want to understand how this Docker and Kubernetes will be used for integrating and deploying into a Java enterprise applications.
Okay, fine. We'll discuss about that. Any another person who want to introduce about himself or Srinivasa? Okay, no problem. Yeah, go on, Srinivas.
Hi, Chaitanya. Myself is Srinivas. Actually, I was a Java developer. Currently, I'm not working. So I want to upskill my knowledge. So that's the reason I'm doing this session.
Right, very nice introductions and yeah. So now let's discuss about the rest of the things. Nagesh, yeah, Nagesh, tell me.
What are this class timings regularly? 8 to 10.
It's 9 to 11.
From tomorrow onwards, it's a 9 to 11.
From Monday onwards, it is 9 to 11.
Nice.
Tomorrow you will have the last demo, and Sunday you won't have any session. And from Monday onwards, it's continuously you will have the sessions.
From 9 to 11.
9 to 11.
Oh,
So let's discuss about the next concept. Else let me introduce you to the main concept of your Docker and Kubernetes. Okay. In the last session, I just introduced how previously the application is developed, how software development lifecycle is there, and how softwares are deployed into the servers. So why we are going from the server to virtual machine and from virtual machine to the containerization. Containerization is also a type of virtualization. There are two types of virtualization. One is hardware virtualization and the other one is software virtualization. When we are discussing about the containerization is called as software virtualization. Again, I don't want to make you very difficult by saying you the critical terminology, but basically it's a software virtualization. Okay, so now what is this containerization? What is meant by a container? So everyone will have this in mind. Is Docker is container or Docker is a software that will have the containers? So the confusion is there. So first thing, let me clarify you one thing. Docker is not containers. Docker is not container. So what is Docker? Docker is a software program or else Docker is an application which will hold the containers. Okay, which will hold the containers. Then what is meant by a container? So first of all, let us see what is Docker. It is a, or else it is an application that holds the containers in a simple manner. If you want to define what is Docker, so Docker is just an application. Then what is meant by a container? For example, now if I open Google Chrome, just for your understanding, I'm trying to explain you this. So I open the Google Chrome. Okay, when I open the Google Chrome, so this is an application. Okay, so inside this application, if I have to access any website, okay, then what I will do? I will go to the search engine, or else in the URL, I will give aws.amazon.com. When I give this, it is going to open a process. It is going to open an application. Okay, this application might be written in React.js or else normal, what I can say, HTML, JavaScript, and CSS, either maybe. Okay, now if I open one more application, this is the Cloud AI, okay, which is an transformer, or else what I can say, it's kind of a chat GPT kind of thing. Okay, so now this is opening an another process here. So to open all these process, to open all these tabs, what is very important for you? For you, it is first of all, you need to open a browser. So what is a browser here? Until unless if you open, you did not open the browser, you will not able to access these web applications. Okay, you will not able to access the web application. So now in the same fashion here, Docker is an application where we can create the containers, in which we can create the containers and we can run the applications. So this is the point what you need to keep in the mind. Now, what is meant by a container? Before I say about a container, first of all, you need to understand where we are creating the container. Containers are created on Docker. Where is Docker? Docker is in an operating system. It's an application which is running inside the operating system. So now, if you see the external architecture of entire Docker, okay, external architecture of entire container, what will be there? First of all, you will have an hardware. Okay, either it might be a laptop, or else it might be a desktop, or else it might be a server. Anywhere you will have the hardware. So you will have CPU, you will have RAM. Okay, hardware, that is CPU and RAM. I am not going to talk about how much CPU, how much RAM, depending on your system, that will be there. Okay, so on the top of this hardware, which means on your laptop, desktop, or else any server, what we are going to do, we are going to install an operating system. Okay, so this operating system is either it might be Windows, or else it might be Linux, or else it might be in the Linux. You will have multiple distributions like Ubuntu, Red Hat, like that. You will have so many distributions. Okay, among that, for example, I will take Ubuntu. Okay, so this is the operating system which we have installed on the server. On the top of operating system, what we are going to do, we are going to install the application or software called as Docker, or else Docker engine. Not only Docker, you will have, if at all, if you are using Red Hat, there is an another type of containerization platform called as Podman. Okay, it is one of the containerization platform, and there is RKT. Okay, like that, you are having so many types of containerization platforms are available. On the top of Docker, what you can do, you can create a container. So what is this container? We'll discuss about that in a few minutes. Container. So on the container, also inside the container, you are going to create an application and its dependency. For example, I want to run a Java related application. So for that, what I will do, I will install Java. Okay, I'm going to install Java. On the top of Java, I will run my own custom application. So this is my backend application. Okay, backend. Now this is how I am going to work. Okay, this is how I am going to work on my container platform. Now, what is this container? What we are trying to do with this container? So not only this container, you will have front-end containers, you will have database containers. We will talk about that. But now the main point is where the containers are created. Containers are created on the top of Docker. So where Docker is created in the host operating system. Where host operating system is installed, it is installed on the hardware. This is pretty clear. Now, for example, there is a user is there. Okay, you have a user and he is an Linux expert. For example, he is an Linux expert. Now, this user he is having a server. Okay, he is having a server and he want to run an application. What are the basic necessities to run that application? What should be there? First of all, or else he want to create a directory inside that particular server. Okay, what he has to do, first of all, there should be an operating system. Okay, so you think operating system is helpful for it's like an interpreter where it is going to interact with the user and the hardware. That is what your thinking is all about. Okay, operating system is a software which will interact with the, or else which will which acts like an interface between the user and the hardware. But here the main point is operating system is only an interface between user, not with the hardware. Okay, so now the user will log in into the operating system to open an application, or else to create something, he will log in into the operating system. Once the user logins into the operating system, now he will type something. So in Linux, there is a concept called as shell. Okay. Okay. There will be bash or else sh. Okay. Bash means burn again shell and sh means burn shell. KSH, ZSH, CSH, like that. There are different types of shells are available. Among that, the most important shell that we are using, or else we are normally using shell is bash. Okay. So now when user logins into the Linux operating system, so he opens a terminal. Terminal is different, shell is different. Terminal is a component. It's an application which will be helpful for you to access the server. But to run the commands, you need to have the bash. Okay. So now he will access the shell. In the shell, he will type certain command. For example, pwd, print working directory, or else ls, list the folders, or else mkdir, I want to create a directory, or else any shell script. Okay, he is going to write all the commands in a shell script and he wants to run all the commands at a time. So he will try to access the shell script. When he executes the commands, the user executes the command. Now what happens? You think that operating system OS will send this request to the server. This is what you are thinking will be all of it. But here, what is going to happen? Actually, in between the operating system and your hardware, there is a component called as kernel. Okay. What is this kernel? Kernel is a compiler. Kernel is an interpreter. Kernel is an interface between your operating system and your hardware. So whatever the hardware devices that you are having, either it might be RAM or else it might be processor, these will be understanding the low level languages, or else I will call it as binary language. Now user is giving the high level language, either it might be in C or else it might be in Linux operating system, whatever the commands that you are providing, that is in the user understandable language. But this language cannot be understood by your server hardware. So now what has to be done? So whatever the user understandable language, that should be converted into the binary language. So I hope that you know, as a Java developers and all the experience which you are having, what is meant by a compiler? What is meant by a compiler? I think 9 o'clock students also joined here, but it's okay. What is a compiler?
Is the application to convert the high level language comments to the low machine language.
Machine language, right? It's a binary. So if I have to simply say that converting the high level language into the, or else user language into the binary language, that is called as a compiler, right? So here the kernel will act like a compiler to convert the user understandable language into the hardware understandable language, that is binary language. Now, without this kernel, the operating system cannot be sustained. Okay, you cannot create an operating system. So if you go back to the Linux history, why I'm telling you all these things means here one thing I have to tell you. Okay, one thing it is interlinked with that. So now when you go back to the Linux history in 1970s, there are two persons called as Ken Thompson and Dennis Ritchie. Have you ever heard the word Dennis Ritchie? Who is he?
C language generator. C language.
Yeah, he is a father of C language. Okay, so Ken Thompson and Dennis Ritchie, these two guys worked in a Bell Labs, and they developed an operating system, high-level operating system called as Unix. Okay, so Unix they have developed with a premium software. They took it as a premium operating system where you have to purchase it. Okay, so then there is a person called as Richard Stallman. Richard Stallman, what he said, I am already purchasing the hardware, whatever the system hardware that I want, I am already purchasing it. Why again I need to purchase the operating system? Why can't I own an operating system? Why can't I develop an operating system? So he has developed an operating system called as GNU. Okay, there is no full form for this, just GNU. So he developed it, and but there is a problem. In 1980s, 85, he has developed this GNU operating system, but there is a problem, that is, he's failed to develop the kernel. Okay, he has developed all the softwares, he has developed everything pretty good, but he failed to develop the kernel. So he don't know how to create this kernel. So now what happened? Until 1990. So in 1990, a person who is the father of Linux is called as Linus Torvald. Okay, so he has introduced a concept called as Linux kernel. So basically, Linux was introduced as a kernel, and which is integrated with GNU operating system. By combining these two, they have developed a concept called as GNU Linux, which is the first Linux operating system or else first Linux distribution. So kernel is that much important for an operating system. It's like a backbone of the operating system. Without kernel, you cannot do any operations. Why? Because kernel is not only a compiler, it can do process management. Okay, which process has to which process has to work first. So the process management will be done, memory management will be done, and then network management, everything will be done by your kernel itself. So kernel is very important for an operating system. Please remember this. But when you're coming back to this concept, so when you see the virtual machines, okay, I'm going back to the virtualization concept. In the virtual machines, there are two types of virtual machines. One is the bare metal virtual machine, and the other one is the hosted virtual machine. Okay, so why I'm talking about that, I will tell you. So here you will have an hardware. Directly on the hardware, we can install the virtualization platform. Okay, so on the top of virtualization platform, we can create the virtual machines. Okay, so what are the different types of virtualization platforms that we are having? So we are having what I can say, VMware, or else we are having one more thing called as hypervisor. Okay, Citrix. These are all comes under the virtualization software. So on the top of the virtual machines, I mean virtualization software, we are going to install the virtual machine. On the virtual machines, or else inside the virtual machines, we are going to install an guest operating system. So guest OS. Guest OS we are going to install. So this guest OS, whatever the guest OS that we are installing, either it might be Ubuntu or else Red Hat or else it might be any another form of Linux. On the top of this guest operating system, we will be installing our runtime. Either it might be Java or else it might be Python or else Node, anything. So for time being, I will make it as Java. On the top of that, we are going to run the application. The same thing happens. Whatever you are seeing in the container, the same thing happens. But the main difference here is, try to understand this one very clearly. So the main thing, what is going to happen? So this particular virtual machine is going to get the hardware resources from your hardware component, the actual hardware components, whatever you are having. From there, you are going to get the virtual hardware components for your virtual machine. And later on the virtual machine, we are going to install the guest operating system. But when you see the containers, we are not going to install the guest operating system. We are not going to install the guest operating system. We will use the operating system environment, whatever the Ubuntu operating system is there. So we are not going to install it. We are just going to install the binaries and libraries of that particular operating system. Okay. This is more important when you are understanding about the kernel. Oh, sorry, when you are understanding about the container. Now, what is going to happen? This guest operating system will have its own kernel. It will have its own kernel. So the application need not to worry about the communication process. This will be happen. So the kernel will convert the user language into the binary language, and it is going to process that particular data. So we don't need to worry about that. But when you are coming to this containers, so containers will be created with an Ubuntu environment or else any operating system environment. Either it might be Ubuntu, Alpine, or else Windows, any operating system. Now this container will use the host operating system. Here you need to understand guest operating system and host operating system. Host means the OS which is installed directly on your physical server. So this is called as host operating system. So this host OS will have its own kernel. So now what happens to run this application, whatever the Java application that we are installing to run this application, container will not have its own kernel. So it will communicate with the host operating system, and it will use the host operating system kernel to allocate the resources for this services, whatever the application that we are running, to allocate the services or else to allocate the resources. So it will communicate with your host operating system, and it will use the host operating system kernel, and it will run the application. So this is the main difference between your virtual machine and the container. So if you can see here, then why we are going with the containers? The virtual machines are heavy weighted. So if you want to move this virtual machines from one location to the another location, one environment to the another environment. So you are a Java developer. You have developed a beautiful application. Now you want to shift that application from the development environment to the UAT environment, and from UAT to the production environment. So if I have to do that, so what I have to do? So I need to maintain multiple images or else multiple package of this virtual machines. But if you can see, if I pack the entire virtual machine, then it is going to create a huge size of virtual machine. So now what I have to do, I need to go with the containers. So containers are the lightweight images where you are going to have minimum 500 MB or else maximum of 1 GB. So when you call it as an perfect image, if the image size is very less when you compare with the virtual machines, maximum 1 GB, less than 1 GB, then it is a perfect image. Now what you can do, if you can see the virtual machines, it is of 30 GB, 40 GB of image size will be there. So that is very huge to move from one environment to the another environment. But when you see the containers, containers are lightweight packaged images which can be moved from one location to the another location very easily. So how we are going to do, I will tell you in detail when we go into the containers. So this is about why we are going with the containers. Okay, whatever you are saying is I'm clearly able to understand that containers are lightweighted so that we can move from one location to another location. But what exactly is a container? You are not saying that, right? So that is what your question might be. So you are not saying what exactly is a container. So please let us know about that. So now let us discuss about what is a container. So up to now, any questions? Do you understand what I am trying to explain here? Any questions? Or else any confusions, or you are unable to understand whatever I am saying? Say it openly, no problem. Either it might be more number of people or less number of people. It doesn't matter. Please know me. Are you able to understand it or not? Come on, guys, open up. No problem. Are you able to understand what we are discussing, what we have discussed until now?
Yes, sir.
Yeah, Chaitanya.
Is it clear? Elvis? If you have any confusions, you can let me know about that. No problem. I will go back and tell you within another 5 minutes. It doesn't matter. Okay. So do you understand what I'm talking? Okay, fine. So yeah, I hope everyone is clear with this. Srinivas and rest of the candidates. Nagesh, Om.
Yeah, yes.
Right. So now go on, Om. Any questions from your end?
No, I got it.
You understand?
Right. So now let's discuss about what is meant by a container. Okay. So before I go into the container, where we are running these containers, that is very important. Containers are running on the operating system. Okay, on the Docker, but Docker is installed on the operating system. So in Linux, there are two features that are available. So what are those two features? The two features are namespace and C groups. Okay. Depending on these two features, our IT experts has created a concept called as containers. What is this namespace? Try to understand one thing. So for example, I will log in into my AWS server first, so that I can show you one thing. So in a Linux mission, whenever we are working with the Linux operating system, okay, whatever the application that we are running, that is considered as a process. Okay, that is considered as a process. So now how I can see the process over here? So to know what is the process that is running in the Linux operating system, we are going to give a command called as ps-ef. This is the command. Remember the command once. So let me access the Docker server. Okay. So just give me a second. Okay. So now we have the Docker server available. So this is my Ubuntu Linux operating system, which I am trying to access now. I will let you know what is this application. If you are very familiar with this concept of accessing the server, then no need. But yes, if you don't understand, I will let you know about it. So when we want to check the process, ps-ef. So these are all the processes that are running on your Linux operating system. Okay, these are all the processes that are running on the Linux operating system. Now the point is, please remember what is the command that I have used, ps-ef. Why we are working with this particular command, ps-ef? Use it to know the process running in the Linux operating system. Okay, fine. Now, what we are going to do, for example, whether Docker is there in this server, Docker is Docker. Okay, good. So now what I want to do here is I want to create a container. So how I can create a container? It's very simple. Now let me show you one more thing. ps-ef, here we have let me do one thing. Grep container. So if I try to pick up the container, we have the Docker running on our system. Now I will install a container. Docker run -itd -name test container. This is the name of the container which I want to create. Test container, and image will be Ubuntu. With the help of Ubuntu image, I want to create this particular container. Okay. So now if you can see Docker PS, we have a test container running on our Docker environment. Now, what is this container? So if you can see ps-ef grep container, here you can see previously we are having user b containerd that is available. Next one is user bin dockerd -hfd. This is also available. And this is available. grep-color auto container. This is also available. But a new process got created. What is this process? Look at that. User bin container d -namespace. There is a namespace. And in this namespace, we got a container that is EAA709. So if you see the container ID, EAA709 63A56B. So this is the container ID. So which means that what happened when we create this test container, when we create the test container, what is happening? A new process got created on my Linux operating system. Let me do one thing. Tmux, I am going to divide this terminal into two terminal with the help of an utility called as Tmux. Okay, terminal multiplexer, Tmux means. So control B, shift double quotes. If you give this, a terminal will be divided into two terminals. Control B, up arrow. Okay, you can go up. Control B, down arrow. You can come to the down terminal. Okay, here, watch -n1 ps-ef. Okay, grep container. CAINER. Okay, I will do with this double quotes so that the command will be executed as a single command. So here you can see there is a process that is running. This is the process which I am expecting. Okay. Now look at here. Docker PS. We have a container running here with the, this is the image ID. Please remember this. Okay. So now what I will do here. So if you can see the third line, you have to remember the third line. Okay. It is running. Now Docker stop. I will give the container ID. When I give the container ID, look at here, we are having the container. Okay, container process is running. If I give the container ID, now what is going to happen? The container should stop. Once it is stopped, then what will happen? The container is running, it is stopped. Look at that, you missed something. Have you checked out when I stopped the container, what happened here? In the top, what has happened here? Are you able to find that process? See, the third process is not there. Whatever EAA709 is not there here. In the process section, we don't have this. If I start it again, then what is going to happen? Look at on the stop. I will try to start the container again. See there, what has happened? A new process got created. When I stop it again, what is happening? I'm talking about this. When I stop the container, what is happening? The process will be killed. So what do you understand from this example? The process got killed. We don't have that process. Now, what do you find in this example? What is meant by a container? Can you tell me? With that particular example, whatever I have discussed, can you tell me what is a container?
It is a process.
Very good. So container is a process. Container is a process which will have the application and its dependencies. Okay, so now when we are talking about a container is a process which will have the application and its dependencies. Now, basically, whatever the container that we are having right now, we don't have any application inside this container. We are having only the environment, only the Ubuntu environment we are having. Now, to discuss about what is this application and dependencies, let me do one thing. Okay, I will come out of this. It will be overwhelming for you, but just look at this. Why? Because I'm talking about the application and its dependencies, right? So now what I will do here is here I am having a Java application is there for me. Where is it? I think the downloads. I have the front end and back end should be there. Where is it? This one. Yeah, backend is there. No? This is what my requirement is. So in the backend, we are having a concept of, yeah, this one. Here I am having student feedback app front end, and we are having the back end is also available. Okay. So now what I will do here is I will zip this folder. I'm going to zip the folder. Okay. Once it is zipped, then what I will do here is I will move this folder into my Linux machine. But one thing I have to check it out once again. The back end, there is some unnecessary stuff is there. Target is not which I want. I don't know it. One second, guys. Choice. I don't want this target. We know about this when we are working with the Spring Boot. You will have the target and all the things, right? 1 second. You're deleting your folder if you continue to try again. Okay, let's see. Go back here. So actually, we don't want the target folder, but that's okay. So I think we have this compressed file that is available. Is it? Yeah, back into this is available. I will do one thing. There is a WinSCP application which is helpful for you to transfer the files from your Windows to Linux. Okay. Right. So now I will connect to that server. What is my server IP? This is my server IP, and the username is Ubuntu. And I want to log in with the what I can say authentication as a private key file. Where is the private key? That is the default key which I am using. Okay, open. Don't worry, it is not a very big thing that you need that you can't understand. I will try to explain you in detail when we go in depth of the concepts. So now here we are having that. So in the downloads folder, the downloads folder, we have the zip files. Okay, this is the zip file which I want. I'll copy it and I will move it to this particular server. Okay, now we are having the zip file. This is fine. Okay, good. So now what I will do, I will go back to my server, cd/home Ubuntu. Okay, ls-la, here we are having backend2.zip. Okay, unzip, zip is available. apt install -y unzip. So to unzip that particular application, we are going with the unzip concept. Good. So now let me unzip that particular folder. Unzip _ backend. So it is unzipped. Now we are having two folders that are available. ls-la, we have the backend folder, and cd backend _backend. Okay, here you are having two folders. One is the backend and the other one is student feedback application. Now let me do one thing. Copy backend to the home directory. Okay. Recursively, I want to copy it with all the files that are there. Copy -r student feedback also. Student feedback to my home directory. So when I copied it, here you can see in the home directory, we are having backend and student feedback application. Now, I don't want to make you more confused about this particular thing. So let me go into the backend. In the backend directory, we are having a Docker file and we are having certain concept called as Maven and all those. I'll do one thing, rm target. I'm going to remove the target folder. Okay, rm-rf. Let me do one thing. So I have removed this target folder. So inside the target folder, what you will have the .jar file. As a Java developer, you know about all these things, right? So when we are using Maven, in the Maven, here we are having form.xml. With the help of form.xml and the source code which we are having, we are going to generate a jar file. And this jar file will be generated in the target folder. Everyone knows about that, right? Come on, Java developers. I want you to answer this question. Is there any Java developer over here? Right. I don't want to make it more long. So here we don't have the Maven. Okay, Maven is not there. So let me install the Maven. Apt install Maven -y. So, but we have a problem. We don't have Java also in this particular server. Let me do one thing. I will install the Java also. Okay, it's working fine. All right, Maven is installed. Okay, and let me install Java also. Apt install -y open jdk -17 jdk. Okay, to run that particular Maven. It's not necessary, but anyways, let me install Java also. I am installing it on the server. Don't get confused. Okay. Right. So we have the Java created. Good. So next one, what I will do here is, if you can see ls-la, uh, we are having a source file and form.xml. Maven clean package. If I give this command, what is going to happen? Maven clean package. What is going to happen? Come on, guys. If I go for Maven clean package, what will happen? Java developers. Okay, so it is going to generate a jar file. Simple concept. It is going to generate a build artifact. Okay, so it is going to generate a jar file. Simple. But there is a problem which we got. We don't have the student database. That's okay. So now what I will do here is, let me show you one thing. Okay, so here I am going to create a student database. Any which way the jar file has to be done. So Maven clean and Maven install. So if I go with this, then what is going to happen? It should generate a jar file. Simple concept. Or else you can do one more thing, -- disk step, skip test. If you view that command, it is going to skip the test also. Unnecessary test will be done, but it is not required. So let me do one thing. -d skip test. So come on, let's go for the skip test. Maven clean install skip test skip test. Copy this. It's okay. So hold on a second. Okay, no problem. Right. So we have a build available in the target folder. We have a target folder which has been created, and this target folder is having a jar file cd target folder. So here you can see we have a jar file created backend -001 snapshot.jar. So this is available. So now what I will do here, cd. One more thing that you need to understand here is to run that backend application, you need to have a database created. So cd src ls-la cd main, and here you are having a resources folder, cd resources. Here it is pretty clearly mentioned that what is the application.properties. Cat application.properties. For a Java developer, it is very easy for you to understand. So we need to connect it to the student DB. Okay, we need to connect this particular application which has been developed in Java, that should be connected to the student DB on the port number 5432. So this is, everyone knows about that. Why I am trying to explain you here means whatever the Java application that we are running. So let me show you in my Docker desktop. So when we convert that jar file into a Docker image, when we convert that jar file into a Docker image, a process will be created. So this process will have the Java application running. So for that reason, I am trying to explain you that concept. So now what I can do here is Docker run -itd name of the file is, or else name of the database is student -db network. I will make it as Java network. We will discuss about everything Java network and all the things. First of all, let me create the network. Docker create, or else Docker network create. We will discuss about this. Okay, don't worry. So what he is doing? He is doing something which we don't know. You don't need to worry about these concepts. We will discuss these concepts in detail about when we are going into the concept of Docker and all the things. But I am trying to explain you what is this concept of containers. Okay, so student DB and -e, the database is Postgres underscore DB is equal to, what is the Postgres DB? The database name is student DB. Okay, student DB and -e. What is this -e? Everything I will explain you guys. Don't worry. Postgres underscore password is equal to Postgres. Okay, and with the help of what I can do with the help of an image called as -v pg wall slash warlib Postgres SQL slash data. And with the help of Postgres image, I want to create this particular container. So when we are creating this Postgres container, what will happen? Actually, a container will be created in the back end. Inside the container, a process will be created. Let me show you that. So ps-ef grep containers. Okay, so if you can see, look at that. A container got created with the name or else with the ID A8190. So inside that you are having the Postgres SQL running. So now what I will do, I will work with Java application, whatever the Java application that we are having, I'm going to work with this Java application. So ls-la, here we are having Docker file. Okay, so this is the main file to create your application or else to create your container. So the Docker file, whatever you are seeing here, this will create an image, and inside the image or else with the image, you are going to create the container. So first of all, let me build the image. Docker build. Actually, this is what going to happen in the backend. Docker build -t Java app version 1 and dot. So now an image will be built and this image will generate a Java application. 1 second. Okay, so it might be confused in the beginning. You are going to get confusions in the beginning. Don't worry about that. We will discuss. But as of now, we have Java version 1, which is created of 6 seconds back with a size of 527 MB. And I am going to create one more container. Docker run -itd name of the container is Java container and network. In which network I want to create? I want to create this in the Java net and hyphen or else with the image Java app version 1. So Docker PS, here you can see we have a Java container created. Okay, Docker logs whether the application is started or not. Java container. So if you can see the logs, So what is happening? JDBC URL connection through database. So database driver is unknown, but that's okay. So it is trying to connect. Okay, here we are getting, there you go. The application is started. The Tomcat started on port number 8080 and the application is started. So now what has happened here, whatever the container that you are seeing here, Java container, inside the Java container, what we are running our app.jar file. From where we have pulled this app.jar file. Try to understand it very clearly. Cat docker file. Here you can see what we are doing, copying the target jar file. Whatever that in the target folder, we are having the jar file. This jar file is copied as app.jar in the container. So inside the container, we are running the jar file with the command java-jar app.jar. So the jar file will be running out. So now what is happening? So from this CD target, whatever the jar file that we have generated, this jar file is copied into the container and it is running inside the container with the java-jar app.jar. So this is the command which you are giving to run the application. So if I want to run this application in my local machine also, how I can do that? Java-jar backend jar. So this I can run, but there I am going to get an error. What is the error means? I don't have the database connected. So I'm going to get an error. So the same command I have given in the Docker file also. So now what happened? That particular Docker file, whatever the Docker file. So here you can see student database is not there. So that is the reason I am unable to connect. So, but when you see the containers here, you are having student database container is available. So it is connecting, the application is directly connecting to the student database and it is starting out. So now if you see the whole process, whatever the process that you have seen here, we created a container. So what is there inside the container? If you read the Docker file, you will understand that. Okay, cat Docker file. If you read the container, so I created an image with the help of OpenJDK 17. I am directly using the image, base image as Java image. So on the Java image, I am running this particular command. So now we don't need to install Java. Already this particular image will have Java, which means that the container is having Java installed in itself. And then it is running the application. So what is a container? If I have to explain you very clearly, a container is a process which will have the application and its dependency. So what is this app.jar? App.jar is my custom application, which I have created. Now, how this app.jar will be running? So without Java, the app.jar will not be running. So what is the dependency here? The dependency is Java. So to make you understand that, let me log on to that particular container, docker execute -it Java container bash. So I will log in into this container and Java -version. So look at that. By default, inside the container, you are having the dependency Java 17 already installed. So we are not going to install all the things. Okay, so now if this satisfies this definition, container is a process which will have the applications and its dependencies, or else container is a process which is running in Docker that will have the application and its dependencies. Will you accept this particular statement? Is it clear for you? Whatever we have seen right now. So you might be, I know you might be totally confused what he has done. He has created some container and then he has created some Java container. But the core point is to run the Java container, what we are using a dependency called as Java that is already installed on the container. And on the top of that, we are running our custom application. So it is pretty clear that container is a process which is running in the Docker that will have the application, our own custom application and its dependency. To run that application, we need to have certain dependency that will be there inside that particular container. Is it clear now? Any questions from your end? Any confusions? So guys, please open up.
Please, sir, how many applications can hold one container?
Actually, by default, it is recommended to have a single application in a single container. but you can have n number of applications, but it is not a recommended practice to have that. Okay.
Okay. So database is no.
Database in a different container.
It is
So
okay.
here you can see the database is available on a different container, Docker, or else if you want, you can create that, but it is going to consume a lot of space. Our intention to create the containers itself is not to consume a lot of space. And one more thing here is databases cannot be on a containers. The database should be on a standalone server. It is not a recommended practice to have the databases on the containers, but to make it very easy for you, I created inside a container. But the recommended practice is to have the database on a standalone server. Why? Because containers are stateless. This is also a very important point that you need to keep in mind. Containers are stateless. What is meant by stateless in the sense containers can be deleted at any point of time. If more amount of pressure has been put on the container, automatically the container will be stopped and the container may get terminated. So in such cases, I cannot put the database inside the container. So it is not a recommended practice to have the databases inside the container. You can have the databases on a separate standalone servers. Am I clear?
Yeah,
Am I clear?
understand.
Right. Any further questions, guys?
One thing, Chaitanya, actually in the Docker image, you did not mention any operating system, right?
That's what I said. Containers doesn't have the operating system. They will have the environment, operating system environment, whatever the binaries and libraries are required, that will be there inside the container, but not the entire operating system. If you take the entire operating system, unnecessary software will come. So when you have the unnecessary softwares, then what is going to happen? Kernel will come, unnecessary softwares will come. That is going to consume a lot of space, which we don't want, right?
It will contain the container of the same type. So because as of now we have Linux, right? So it will create the Linux container. For example, I want to install on Windows, so it will be a window
No,
container.
it's not like a Windows container. So if you can see in Windows itself, I install the Docker Ubuntu containers itself. See, on my Windows Docker desktop, whatever the containers that I'm running here, these are all the Ubuntu containers itself. It's not like only on Linux environment we need to run the Linux containers, or in Windows environment. Windows containers are not seen. Okay, mostly you'll have the Linux containers itself. Now you have a question. Then how Linux containers are running on the Windows operating system, right? Yes or no?
I know that there is some virtualization software that will make use
No,
of that
that
container.
doesn't have a virtualization software. In Windows, if you are using in Windows, there is a concept called as WSL, Windows
Yeah.
Subsystem for Linux. Okay, this application should be installed at the time of installing the Docker, so that the container which is installed in Linux, they can understand the kernel language of Windows. So this will act as a mediator between the containers and your kernel. Okay.
Actually, after installing the application, you just logged into the other console, right? Other terminal. So that is new OS, right? Or the existing
No,
OS.
this you are talking about Java container. Just
Yeah.
I just logged on to the Java container. Here you can see we have a shell. Okay, so if you see shell, what is the shell that we are using? Most probably bash. If you give the bash, so this is something different. So if I have to know about that, cat etc os-releases. So if you can see, we are using Oracle Linux server. Okay, so this is not which we have installed. Okay, so automatically in the image, what is the what is the base image that I have taken here when we are creating the container, or else when we are creating the image cat Docker file. So here you can say I'm directly taking OpenJDK 7, which means that it is already have the base image available. So I'm not going to take that. I will tell you when we go for the images, then you will get a more clarity on this.
So you mean to say that from OpenJDK it got installed that particular OS,
Yes.
binaries, right?
Yes. Okay,
It
but
has
how
the
this
same the file system under it has its own file system, or it will use the existing the host.
it will have its own file system, but see, the point is the containers in the backend will not able to store the data. If they store the data also, it's a temporarily storing. Okay. So once the container is deleted, the data will be deleted. So to store the data permanently, it has to be created in our Linux operating system or else host operating system. I will tell you. We are having a separate concept called as Docker volumes. We will discuss about that.
So in the copy, you are copying target backend snapshot jar to app.jar. So that will be stored in the container file system, right? App.jar.
So this is generated in the host file system backend.jar. So whatever the backend.jar which is generated in the host, that will be copied into the container as app.jar.
So you are creating the directory hyphen app. What is that working directory?
One
/
second. Now you don't understand the things. Okay. So I'm just keep in mind that we are using the containers to run the applications. I just want to show you that applications will be running inside the containers with its dependency. What is a container? Container is a process. To make you understand all these things, I have created all these configurations. But if I have to explain you all the things in the demo sessions, it is not possible. Okay. Once you get enrolled for this, I will make you understand about what is meant by Docker, Docker networking, Docker images, inside the Docker images, what is going to happen, and with the help of Docker volumes, what we can do, how actually the application will be running inside the Docker, everything I will tell you at that time. Okay. But to justify this particular statement, I have given the entire application for you. Okay. If I have to tell you in a simple manner, I can tell you container is a process that runs in the Docker, which will have the application and dependency. If I state that, that's a statement which everyone can learn. But if I show you in a practical manner, you will understand. So that's the reason I have shown you all that particular thing. But now, if I have to explain you, that is not possible. Okay. Once we get into the Docker, I will try to explain you everything. Any further questions? Questions, guys?
No.
Okay, then. Have a nice day, and we'll meet in the next session. Bye-bye.
And Chaitanya, just I have one question. So
Mhm.
not about this doubt. So this class, it will be 8 o'clock or 8 a.m. or 9 a.m. Hello?
Yeah, it will be from 9 a.m. to 11 a.m.
9 a.m. from Monday onwards, right?
From Monday onwards.
Okay. Because I have
Okay.
checked with the admin people, so they are not able to tell like properly. So I thought that okay, let me check with you.
Okay.
Okay.
Okay. So it will be from 9 a.m. to 11 a.m. Any further questions?
No.
See, the session is from 9 a.m. to 11 a.m. You will get the videos, you will get the documents with you. And with the help of this course, you can able to complete the certified Kubernetes administration certification. Okay. So I made it very clear for you. Sorry, there is another session that is happening on the same link. So I have to discontinue this session. If you have any further questions, you can note it down and you can ask me in the next session. I'm very open for you to all to explain all the things. Okay, tomorrow you will have the session at 8 a.m. And from Monday onwards, the session will be at 9 a.m. Those who has enrolled for the session, they will get the link and you will have that link with you and you can join into the sessions. So have a nice day and bye-bye. Sorry, I'm discontinuing.